Hello students, welcome to Learner's Planet. I welcome you to this session of metals and non-metals. In this session we are going to discuss about the reaction of metals with water. Also the non-metals with water. That is the type of products these metals and non-metals form on reacting with water. We'll also discuss about their reaction with acids. So let's start our session here. Let's see how metals react with water. Metals react with water forming hydroxides. Say for example sodium. It reacts with water forming sodium hydroxide and hydrogen, and also heat is released. So sodium, the symbol is Na. It is from the Latin word natrium. That is, Na is from the Latin word natrium. Reacts with water forming sodium hydroxide. See, OH is here. That is why it is named as hydroxide. Hydrogen gas is evolved, and also what is released is heat. Right? Next is potassium reacts with water producing potassium hydroxide and hydrogen gas. In this case, see, potassium solid, it reacts with water forming potassium hydroxide. What is there is OH is there. That is why it is called as hydroxide. Hydrogen gas is released, and a large amount of energy is released in the form of heat. This reaction is so violent that hydrogen gas evolved catches fire. As soon as this hydrogen gas is evolved, it catches fire. So the reaction of metals like sodium and potassium with water is exothermic. Exothermic. What do you mean by exothermic? That is, proceeds with the evolution of energy, and that energy will be evolved in the form of heat. Right? Other metals react with water, again forming hydroxides, but the reaction is not exothermic. Got my point? Say other metals like calcium, they also react, calcium, magnesium, they also react with water. See, calcium reacts with hot water forming calcium hydroxide. Right? So in this case, forming calcium hydroxide and hydrogen gas. It is not hot water, it reacts with cold water only. Right? So calcium reacts with cold water, releasing hydrogen gas and forming calcium hydroxide. Right? So in this way, metals react with water, forming hydroxides. See what is happening here? It is potassium. When it is put in water, you get sparks like this. Energy is liberated. What is formed in this solution is potassium hydroxide, that is KOH, and what is evolved out? See, what is formed here is hydrogen gas. So this hydrogen gas will be evolved and it catches fire. Now let's see how non-metals react with water. Non-metals generally do not react with water. We have large number of non-metals. You must be knowing about the carbon, about oxygen, about nitrogen, hydrogen. They do not react with water, right? Normally, they do not react with water. There may be few non-metals which react. Now, though they may be very reactive in air, they do not react with water, but they are very reactive in air. For example, phosphorus. Phosphorus is highly reactive and it catches fire if exposed to air. To prevent its contact with air, it is always stored under water. Got it? So this is the difference between the chemical property of metal and non-metal. That is the reactivity of metal and non-metal with water. Now let's see how metals react with acids. Reaction of metals and non-metals with acids. Metals react with acids producing hydrogen gas. Right? With some metals, the reaction is very fast and vigorous. Vigorous means evolving large amount of energy in the form of heat. While with the others, it is slow. See here, it's sodium reacts with hydrochloric acid. Hydro, it's for H. Cl, chloric, and it's acid. Always remember, see, an acid is having H ion, H as a basic component. See, H2SO4, H is always there. HNO3, that is what? Nitric acid. Here also H is there. And a base has hydroxide. Like sodium hydroxide, OH is there. It's a base. Base turns which litmus what? Red litmus blue. And acid turns blue litmus red. Calcium hydroxide, this is also a base, right? Potassium hydroxide, this is also a base. So what is the difference between acid and a base? Acid is having H and potassium hydroxide, these are having hydroxide entities, that is OH. In this case, see, sodium reacts with hydrochloric acid forming sodium chloride. Na is for sodium, Cl for chloride, and hydrogen gas is evolved. Right? Zinc reacts with sulfuric acid to form zinc sulfate and hydrogen. See, zinc with sulfuric acid, the formula is H2SO4, forming zinc sulfate, ZnSO4, and again hydrogen gas is evolved. How it is found that hydrogen gas is evolved? It is hydrogen gas produced burns with a pop sound when a burning matchstick is brought near to the test tube. See if the reaction is going on in this test tube, right? The reaction of sodium and hydrochloric acid forming sodium chloride and hydrogen gas. In this case, hydrogen gas will be evolved here. This is H2 gas. If a burning matchstick is brought near to it, it will burn with a pop sound. Right? Zinc likewise reacts with H2SO4 forming zinc sulfate and hydrogen. Zinc also reacts with hydrochloric acid forming zinc chloride and hydrogen gas is evolved. Always remember, metals when react with acids, hydrogen gas is produced. Right? And rest of the compounds you can form by just combining the other ones. That is in this case zinc with chlorine. Magnesium reacts with the sulfuric acid to form magnesium sulfate and hydrogen. See here, what is to be done is this H2 is evolved as it is, and what is left is magnesium and sulfate. Just combine the two. What will be formed here is magnesium sulfate. Right? Likewise, aluminium reacts with hydrochloric acid to form aluminium chloride and hydrogen. See here, this is aluminium. It is reacting with hydrochloric acid, forming aluminium chloride and hydrogen. So do remember, whenever metals react with acid, what is evolved is hydrogen gas. Right? And in case of non-metals, they generally do not react with acids. They generally do not react. Right? Then reaction of metals and non-metals with bases. Metals react with sodium hydroxide producing hydrogen gas. Say for example, let's take up aluminium only. See, aluminium reacts with sodium hydroxide producing, and this is the heated one, heat. It will produce sodium aluminate and hydrogen gas is evolved. This is sodium aluminate. You don't need to remember this. Just remember that metals like aluminium, tin, lead, this is tin, right? Lead, zinc, react with sodium hydroxide producing hydrogen gas. See, sodium hydroxide is a base. It has got OH thing here. So metals react with sodium hydroxide producing hydrogen gas. Non-metals undergo complex reactions with NaOH. You'll be studying about these reactions in your higher grades. Let's see a few more reactions of metals and non-metals. Displacement reaction. What is this type of a reaction? Let's see what happens. When a more reactive metal is put in the salt solution of a less reactive metal, the more reactive metal displaces the less reactive metal from its solution. Salt solution means, say, a salt. Here, copper sulfate is a salt. Sodium chloride is a salt. Right? Likewise, potassium sulfate is a salt. So in this case, there is a salt, that is copper sulfate. The salt, it is dissolved in water. That is why it is saying that salt solution. When a strip of zinc is put in copper sulfate solution, what happens? The blue color of copper sulfate solution fades due to the formation of colorless zinc sulfate, and copper metal is deposited on the strip. In this case, see what is happening? Zinc is more reactive than copper. Okay? So when zinc strip is put in copper sulfate, which is a salt solution, salt dissolved in water. When the zinc is put in the copper sulfate solution, what happens? Zinc displaces copper. That is, zinc comes in place of copper and forms what? Zinc sulfate. SO4 is for sulfate. And what will be left free from here is copper. The reaction takes place like this. See, I'll tell you. Copper sulfate plus zinc. So in this case, what happens? Zinc displaces copper and forms what? Zinc sulfate. And what is liberated or what is formed here is copper. Right? Copper sulfate is blue in color. Copper sulfate solution is also blue in color. But zinc sulfate is colorless. See, zinc sulfate compound is colorless. Copper sulfate compound, this salt is blue colored. But zinc sulfate is colorless. Right? Salt, it's not just the table salt which you're eating. Table salt is sodium chloride. There are many other salts available, are formed actually. So zinc displaces copper from copper sulfate and copper gets deposited on the zinc strip. This reaction is called as displacement reaction. See, in this case, this is the copper sulfate solution, which is blue in color. This is zinc rod. Now what is happening? Zinc from zinc rod is forming what? Zinc sulfate. And what is happening? This copper which is present in the solution gets deposited. See, this zinc rod is broken there, because zinc from rod is dissolved in the solution, forming colorless zinc sulfate, and copper particles are there, right? So the color of solution becomes light. Initially it is dark blue and then it becomes light in color. Why so? Because of the formation of colorless zinc sulfate. This reaction is an example of displacement reaction. That is, the more reactive metal or more reactive element displaces a less reactive element from its salt. Let's take one more example. Copper sulfate plus iron nails forms ferrous sulfate, ferric sulfate. It is ferrous sulfate. Copper sulfate plus iron nails, that is iron is dipped in it, forms ferrous sulfate and copper. Right? So what will happen? Ferrous sulfate is green in color, or you can say iron sulfate here. Copper sulfate, iron sulfate. So that is green in color. Right? So the color of solution changes from blue to green. Copper is displaced from copper sulfate by iron. So copper is released out. This copper deposits on the iron nail. Right? So this is also one of the example of displacement reaction. When copper is placed in zinc sulfate solution, there will be no reaction. Why? Because copper is less reactive than zinc. So copper cannot displace zinc from zinc sulfate solution or zinc sulfate. Likewise, when iron filings are kept in zinc sulfate, then also there is no reaction. Why so? Because iron is less reactive than zinc. So remember one most important point, that a more reactive element displaces a less reactive element from its salt. Right? So copper cannot displace zinc because copper is less reactive than zinc. Likewise, iron cannot displace zinc because iron is less reactive than zinc. Okay? You know, there is an activity series of metals in which metals are arranged according to their decreasing reactivity. It is, the first metal here is potassium. That is, it is highly reactive. Right? The second is sodium. It is less reactive than potassium. See, I told you potassium, the reaction of potassium with water is vigorous. Hydrogen burns. The hydrogen gas evolved in the reaction burns off. Right? Whereas sodium, the reaction is not that vigorous. Then the third metal is calcium. Fourth is aluminium. The fifth metal is zinc. Then comes iron. Then comes tin. Then is lead. Then is hydrogen. Hydrogen is kept among metals, right? And it is a non-metal also. Then copper. Then is mercury. Then is silver. Then is gold. And the last is platinum. So which is the most reactive metal? Potassium. Which is the least reactive metal? Platinum. Now calcium can displace sodium from its salt solution. Cannot displace, right? The ones which are more reactive will displace the less reactive from its salt solution. Aluminium will displace zinc from its salt solution. Had this been zinc sulfate plus aluminium, the reaction would have been aluminium sulfate plus zinc. Right? So this is the metal reactivity series. And hydrogen is taken as a comparison over here. So hydrogen is placed in metals as well as non-metals. Do remember this. So this is a decreasing reactivity of metals. The metals lying above are more reactive than the metals lying below. And the metals lying above can displace the metals lying below from their salt solution. Okay. So these are all the reactions of metals and non-metals. Did you enjoy this? How these elements react? I really like these things, the reactions, the products and the color change. Now let's see what are the uses of metals and non-metals. Metals, as you know, iron. Iron is one of the metals which is widely used. It is used in automobile industry, in construction and also for making large number of tools. Right? A spade and many other tools are made from iron. Gold and silver are used for making jewelry. Silver is also used for making utensils. Say silver plates are there, silver bowl is there, silver glasses are there. Copper is used for making electrical wires and cooking utensils. Why so? Because copper is a very good conductor of electricity. Also, it is a good conductor of heat. Zinc is mainly used for making protective coating for iron to prevent it from corrosion. I told you when iron is exposed to atmosphere, what happens? Iron reacts with water and oxygen, forming a compound called as hydrated ferric oxide. This is what? This is hydrated ferric oxide. That is rust. That is a brown powder. This is what? This eats up the complete iron metal. So zinc is used for putting a protective coating over iron. See this protective coating over it so that iron is not exposed to the atmosphere and prevented from corrosion. Aluminium is used for making electrical cables because it is also a very good conductor of electricity. For cooking utensils because it is a good conductor of heat also. Right? It is used for making water boilers. Why? Because it is a very good conductor of heat. For making aeroplanes, you know one of its alloy, that is duralumin, is used for making aeroplane body. For trains, it is used in trains for automobiles. It is also used in industrial gadgets. So there are a number of metals and they have got wide use in our daily life. These are few of them. Likewise, non-metals. Non-metals are also useful for us. One of the non-metal which you breathe in is oxygen. right? See, non-metal is used in water purification process. Chlorine, see, chlorine is added. It is used as a disinfectant, Cl2. It is added to water for killing microorganisms. So it is used for the water purification process. In the swimming pools also chlorine is added. It is a very good disinfectant. Non-metal used in purple colored solution which is applied on wounds as an antiseptic. It is tincture iodine. Tincture iodine. It is also what? A non-metal. This is also, it kills the organisms. If you have got a wound or something else, a cut, a bruise in the skin, just this tincture iodine is applied and it kills the microorganisms, whatever comes in contact with the cut or the bruise. Non-metals are used in crackers also. See, nitrogen, it is used for making crackers. These are few non-metals. Say sulfur. Sulfur is a very important non-metal. Sulfur is used in the manufacture of compounds such as sulfuric acid. Sulfuric acid is called as king of chemicals. Do remember this. Sulfates, right? Sulfur is also used in many other industries like pigments, fibers, pharmaceuticals, agricultural pesticides, personal care products, cosmetics, synthetic rubber vulcanization, water treatment and steel pickling. These are all the industries where the sulfur is used, right? Sulfur is actually mixed in the natural rubber in order to increase or enhance its good properties, that is its elasticity, enhance its temperature at which it melts. So this is called as synthetic rubber. Vulcanization is the process. That is when sulfur is added to the natural rubber. That process is called as vulcanization. Sulfur is also an essential plant nutrient. Even phosphorus is an essential plant nutrient. Nitrogen is an essential plant nutrient. But we put in sulfur and phosphorus. Plants, they fix atmospheric nitrogen. Fix means they can use atmospheric nitrogen with the help of bacteria present in the soil. Likewise, the uses of phosphorus. Phosphorus is used in the fireworks industry and for making special glasses used in sodium lamps. You have to just remember this. Graphite. Graphite is used in pencils and also in brake linings. So these are some of the non-metals whose uses I have discussed. There are many more non-metals, there are many more uses, but you just remember this much. And a non-metal which you breathe in is oxygen, that is O2. A non-metal which is filled in balloons is hydrogen, or helium is also used. Right? So this is all about the topic of your metals and non-metals. I hope you have enjoyed these sessions and also I hope you have understood the reactions. Thank you students for being with me. Thank you for listening patiently. Just go through your text once and just learn the reactions. Right? Reactions you have to by heart. You're getting 3, 4 and in the later stages you can just make the chemical reactions. You can write the equations for the chemical reactions. But for now you have to learn them. Right? Thank you very much and do have a nice time ahead.